Hi guys, this is power supply number 4 from the Hall of Shame. First I'd just like to say a big shout to Farben, one of my subscribers who asked me to repair this one next. So hi Farben, hope you're enjoying the videos and hope you enjoy this one. Let's see if we can fix it, eh? Okay, so I tried it previously, it was powering on for 2 or 3 seconds and then powering off again. I've got it connected to the light bulb. I've got both the 100 watt and the 60 watt, so 160 watt limiter on this, all plugged in, basically ready to go. So I think the first thing, we'll just apply some power to this. I've connected the 12 volt 6-way and 4-way, the 24-way, it's all on the analyzer. This is on. This is set to limit. So let's give it some power and see if it's still doing what it was doing when we tried it previously. Powering on for 2 or 3 seconds, then back off again. Let's have a look. Right, that flashing, that's the PFC. It doesn't seem to like, I've had a lot of power supplies don't seem to like this, yeah. So it gets flash on, flash off, flash on, flash off. So I'm going to set this directly to live. I'm just going to power it up without the limiter in circuit to see what it does now. Yeah, it is now running for a couple of seconds and then goes back off again. So that's the nature of the fault. Now let's see if we can see if all the voltages are there or what's missing. I think maybe I noticed there maybe the 12 volts was missing, yeah. So let's have a look. We know this has active PFC to start with because of the way this was behaving, yeah. So let's try it again and let's see if we can determine if all the voltages are there or not. Yeah, what happens is, I don't know if you can see that, maybe my head was in the way. It looks like it comes up and then the 12 volt goes off and then it powers off again. Okay, let's zoom it in well. I don't have a slow motion camera. That'd be fun, wouldn't it? Yeah, let's give it another go again. Let's just see if we can see what it's actually doing. All there, then the output seems to go off apart from one, and it shuts back down. When they are there, the voltages seem to all be okay. On. Yeah, they all go off apart from 5 volt standby and then it shuts down. So that's what it's actually doing, yeah. Okay, so we have an interesting fault. Let's open this up. We know this one won't be dangerous. We know that the big capacitors won't be storing a high voltage because it's effectively drawing power and shutting down. So during that shutdown, I'm pretty sure this will be discharging the main capacitors. But let's have a look. Okay, so I've just zoomed the camera out a little bit so we can see what's going on with this one. I'll take my analyzer off because the thing was sort of flapping around here. So we don't need that right for now. And let's see if we can get into this one. There's got to be some screw somewhere. One over here. Oh, it looks like this comes off this way. Okay, I'll see if I can get it apart. One moment. Whoa, Farbin, what have you picked, man? What have you chosen here, you bugger? This thing's a beast. Look at this. Look at this, man. That's nuts. I've never seen so much in an ATX power supply in my life. What's this thing rated at? 410 watts. Whoa. No, 410 watts continuous, 470 watts surge for 10 seconds. Oh man, what is this? Okay, I'm going to have to figure out how to get this apart. It looks like there's screws holding this top PCB. And then this is the other PCB, yeah. Can we see where the main... Oh, yeah, I can see the main capacitors all right. Main capacitor is here. Yeah. It's a huge bloody thing. Well, we can check if there's any high voltage in this. We can get this off here, yeah. Now you can see there that's the main capacitor on this thing here, yeah. so we can see if it's safe. My guess with this, by the way, before we go to part, is capacitors, output capacitors. I think it's, yeah, okay, it's safe. Look, guys, it's saying 0.5 of a volt. Yeah, so we know that's a safe thing to work on. I've never seen anything like this one. I've never seen one like this in my life. How old is it? Well, no, it's got like a 24-way ATX, so it can't be that bloody old. I mean, and it's got a 6-way and an 8-way on here, so it can't be that old. Made by Volvo or somebody. This is built like a bloody tank, yeah. Bloody, you know, Volvo or Hummer or somebody made this thing, I'm sure. So it's like a tank. Okay, let's see if we just get the focus a little bit better on that camera for you. I have no idea why that camera varies. It's a manual focus camera, so I'm setting the focus. You know, it's not like it should be able to change. I don't understand why or how the focus is varying. Well, yeah, autofocus. You know, you can understand something's going on, but with a manual focus, that doesn't make any sense. Well, this board's loose. This board's loose to some extent, yeah. Just move that out of the way a little bit, make a bit of space. What's inside from this side of it? I'm not even sure I'm going to get this apart to actually work on it yet. Well, if I can power it up and work on it, it'd be interesting. Okay, 3 screws on this side. Yeah. Here's the other board. That's loose as well. It looks like all this will kind of like come out from the back, but there's like where the power's coming in, and if you see down here the wires that seem to be holding all this, yeah. Oh, another screw, that might help, you know. That might help. Take the screw out, that might help a bit. Oh, that does help a bit. So, this board is now... Whoa. It's all coming apart. It's all falling to bits. That bump. Yeah. Get that off. That's the fan. Okay. Let's split this into two. It's got a big. There's a big connector here. Yeah. Which seems to join the two circuit boards together. Oh, it does join the two circuit boards together. Never mind. Seems to. It does. Yeah. How do we get that off there? With a sorry guys, you can't see. Let me just get it apart and you'll be able to see what I'm doing. Okay guys, well it's apart, yeah. So this is like the casing thing. I ended up desoldering the live and neutral wires from this board. So they were coming in near the fuse over here, yeah. The two holes here, live and neutral. So we have two circuit boards here. We have a big 450 volt capacitor. We know this has active PFC because of the way it was behaving with the light bulb. So we know that much, yeah. It looks like this is probably the PFC. So you've got the fuse here, power coming in. These are filters to stop any interference getting back down the mains. This will be a VDR. Voltage dependent, this will probably stop over voltage plugged in, although I'm not quite sure how that could happen. Bridge rectifier attached to the heatsink, yeah. And then we've got a big inductor, a big capacitor, and a heatsink. And on this heatsink, if you can see, but we have two big devices that look to be the same as each other. So 1, 2 here, yeah. And then a smaller one with 2 pins. So that looks very much like two MOSFETs, K2689 are the MOSFETs. Can read the number on one of them, K2689. Probably two MOSFETs and a diode, and that's a PFC circuit, I would say. This looks like a temperature sensor, this thing here, yeah. So I'm pretty sure this is the PFC, and then from this connector here, which actually, if your loop is connected these two pins and these two pins, this is your output of your main capacitor. So your 400 volts or so DC appears here on these two pins, yeah, and that then goes on this connector up into this board. Looking here, we can see here we have a transformer, yeah. There's a transformer here. We have another transistor or something under here, yeah, another one here. But we have three opto isolators and a transformer, so we can see this is the transformer, this is the gap, yeah. So I would suggest these where your opto isolators obviously are. There's a gap there, and there's like a kind of a big gap here. So I'm pretty confident this is all on the low voltage side of the supply, yeah. This is all on the low voltage side. It could be that this is your 5 volt standby, but I'm not totally convinced. There's a transformer there. There's some device down here, so it's possible this is your 5 volt standby, this transformer, and this is on the low voltage side. It's possible. And then there's this little connector, yeah, which goes up onto the other board here. Okay, so that's what we have here. PFC, and I would think probably the 5 volt standby is on that board. Then we have this. And look at this connector here that goes from this board to this board, yeah. There's no markings, you know, on the board to tell you, like, you know, what voltage is what. It doesn't say anything. Doesn't say anything on this end, so there's no kind of guidance. But we seem to have like orange, red, yellow, and a number of wires here. There's certainly more wires here than you'd expect to have on the 5 volt standby supply. Yeah. Quite a few pins coming off that, so I'm a bit uncertain. The fact we've got a transformer here makes me think it's 5 volt standby, and I can see a driver device, and it's possible there's a controller. It looks like there's a controller here. There is a controller chip here. That could be for the PFC. I'm kind of guessing that's for the PFC, or assuming, yeah. So that brings us to this board. So this is where the power comes in from here, from your main capacitor. So this will have like about 400 volts DC on it, and that just goes into here. Now looking at this one again, I can see there's a gap here, yeah, there's a gap, and under that gap is a coil and a transformer here. Yeah, it's a transformer there, and it looks like some sort of coil here. So I'm guessing, well, so I'm not guessing, I've got a very good idea that this here is high voltage side again, yeah, and then this side of the gap is a low voltage side, yeah. We also have here quite a hefty transformer, and again it's bridging this gap, yeah. And also on here we have a heat sink, and under the heat sink, under here, I can see two transistors or FETs. I can see a little transformer here, yeah. So based on what I know from other designs, it's looking like the power's coming here. This is your main drive, your FETs or transistors driving the main transformer, yeah. This little bit of circuitry up here, I'm not rightly sure what this is. I can't just consider what that is, but it's on the low voltage side. I'm confident this is all on the low voltage side. So whatever this is, it's on the low voltage side of the circuit. Yeah, I'm not right sure what it's doing, but it's on the low voltage side. There's 1, 2, 3, 4, 5, 6. There's about eight devices bolted to this. Yeah, whole load of stuff bolted on this heatsink. These are going to be these, I'm sure, are all going to be rectifiers, and the reason being they're all on the low voltage side. Yeah, this is all on the other side of this gap. So the only high voltage circuitry is this bit here, which would be the driver for the transformer. This is your main transformer. So the secondaries come out here. These are all rectifier diodes, I would say, or maybe voltage regulators as well. There's another one tucked in here, another voltage regulator or something. Output chokes, inductors, output inductors, lots of output capacitors. Yeah. And this connects to the other one of these. So this circuitry here is connected into this as well. I still think this is a 5-volt standby because I can't see anything else that could be 5-volt standby. This little transformer down here, I'm confident is driving the main switching transistors. Yeah. So on the low voltage side, lots of output inductors, lots of capacitors, all of which look fine, by the way. I don't see any problematic looking capacitors. I'm not saying we don't have any, but they don't look like they're bad. Yeah. And then on here, I would have to assume there's a lot of chips on this board. This board here has a lot of chips on it. But I'm pretty much assuming that this is all like voltage comparators that are monitoring all the various output voltages. One of these is the driver that's driving back via this little transformer here into these transistors. And you'd expect there to be a couple capacitors down there as well. Can't see very well. Okay, that's what I think we have. What's wrong with it? Good question. The way it's behaving, it's like, obviously it powers up, so all this stuff can work. It powers up, and I think that this sees something it doesn't like and then tells it to shut back down again. Whether there is something it doesn't like, or whether it's a kind of like it's detecting a fault that isn't there effectively. Yeah, it thinks there's a fault, but there isn't a fault. Like, for instance, like say there's an overcurrent resistor and the resistor's high value, so that it gets a higher voltage than you'd expect, and this is, oh, too much current, but there isn't really. I think it might be something like that, you know, guys. Okay, well, it's going to be fun trying to repair this. I'm just looking over to see if I can see any bulging capacitors, because that would be a very good place to start, you know, with this. And I don't see any. No, I don't see anything that looks suspect on this at all. I mean, there's so many, it's easy to miss them, yeah? Okay. Then the first thing we'll try and do is obviously if we find a schematic for this. It says it's Newton Power Limited, yeah? And it's got a model number on it, NPS 400 AP. This also says Newton Power Limited. DC2007, it's got a different number, yeah. The power supply is a Newton Power Limited, NPS 400 AB, which matches what it says on this board, yeah. AB, okay. Let's see if there's any schematics on the internet for this power supply, because that's going to make things quite a bit easier for us. Let me have a look. Now, unfortunately, I couldn't find any schematics for this at all. I did ask on Badcaps forum, see if somebody had them, but they don't. But I think really we've identified all the main sections of this. The fact it's a bit of a beast doesn't really mean it has any, you know, operate in a different way. It's just heavy duty effectively. This makes me wonder, some of those 500 watt power supplies ATX that have got bugger all in them. And you think this can't be 500 watt, and if this is what it takes to really drive, like, you know, 470 watt peak power supply, then those things can't possibly be the rated value. We'll look at that later. We'll have a look at getting some sort of load and trying a few, I think. Talking of load, I'm wondering first at this, if we'll connect the analyzer back on, and let's connect like a couple of old hard drives or something onto here, yeah. Let's give it some load, because it's just occurred to me that it might be the situation that this won't power up without a load. It can happen with power supplies. I think we need to eliminate that, otherwise we could spend quite a bit of time messing around trying to fix a fault that isn't actually there, yeah. Another thought I had was this connector here. I was commenting there seems to be quite a lot of connections on here, yeah, more than you would expect if this is a 5-volt standby. Now, if we turn this over and we have a look, and I'll just zoom down a little bit on this, it looks like we actually have here like probably a ground somewhere and 2 voltage rails coming off. You can see like there's 2 pads here together, there's 2 here together, there's 2 here together, and I'm suspecting one of those is ground. Probably if we look at the wires, we've got 2 orange, 2 black and 2 red, yeah, and the 2 black go to the middle lot. So I'm pretty much taking an assumption, I think it's probably a good one, that the 2 blacks are ground and then the other 2 are 2 different voltage rails. One will be a 5-volt standby and the other one would be a power supply into this controller. If you saw one of the previous videos, we had a fault whereby the 5-volt standby was okay, and there should have also been a 24-volt supply coming from the 5-volt standby transformer on a different winding. Instead of 40 capacitor, it was only 8.7, it wouldn't power up. So I'm thinking now we've probably got like 5 volts plus something else coming off here, yeah? And that's powering up this control circuitry. The other wires, and I commented that there's quite a few wires. Well, we have over here the opto isolators, yeah, 3 of them. And if you look where they are here, they are kind of connecting to this as well. So I think the other connections are probably control signals for these opto isolators. There seems to be 3 going that way. There's 3 opto isolators. That sort of makes sense. And then that just gives us one more here which disappears into this lot somewhere. Not sure exactly what that might be doing, but it's sort of like we don't seem to have so many mysterious pins on that connector anymore, yeah? Now then, how are we going to test it? Well, on the bench obviously, but I think the easy way with this is if we solder a couple of wires onto here with an IEC, like a main socket on it basically, yeah, then we can plug the power into here directly. This we can put flat like this and we've got the connection between the two. That just leaves this. Now this feeds the high voltage from this capacitor, maybe 375 400 volts to there, yeah. And I thought initially to actually just take a little connector like this one, yeah, that will fit on here, okay, and then solder and obviously put some heat shrink on insulation and use some wires that are suitable for the high voltage and effectively connect that to this so it's all flat on the bench, yeah. And I was going to do that, and then I thought, hang on, what if you just turn it around like that? So if we turn it around this way, you can see that we can actually connect this, yeah. We can actually do it like that. So we've got the 2 boards now plugged together. We can just move this one out of the way and we can test it that way, yeah. I mean, if it gets a problem, we could always make up a longer lead. I mean, sometimes you'll find when you're working on stuff, you may have to make up like extended cables and things so you can get it into a position where you can actually work comfortably on the item, or you can actually get to what you need to get at, yeah. So that's not unusual. And I've done it myself, you know. I've had to make up extension leads, effectively extending wires so I can work on something. So anyway, because it's all high voltage and this is a ESD mat, I know it's not conductive, but I don't like putting high voltage things on it, yeah. I'd much rather take like a, you know, something like this, just stick it underneath, yeah. Just beware of the fact, I've just realised some I was just going to do this, yeah, and here we have staples. And you think maybe that's not quite such a good idea. Now we don't have staples, yeah. Now we don't have staples. These are the stupid things you have to watch out for, I tell you. When you've been doing this for as many decades as I have, you've never seen everything, but you've seen a lot of things, yeah. And you notice, you look for things like that because you've seen it before. Okay, so we'll have it like this. We'll power it up. I'll solder a couple of wires on so we get the mains onto it, and let's put a load on and see if it now powers up or not and stays on. We know it powers up, but will it stay on with the load? Okay, so I've got it plugged in with the power supply tester on there. I've soldered, it's just a socket with a couple of wires. Actually, I remember, I mean, years ago, back in the 80s, I had some electrician or some guy in the house. I used to repair TVs then, as a sideline, and this was like CRT TVs, yeah. And they had like a piece of wire with the mains plug on the end and two bare wires on the other end. And this guy chewed my ear about having this and that. It was so dangerous, yeah, to have a piece of wire with the mains plug on one end and two bare wires. And it's not dangerous. It's just like you need to respect and know what you're doing, yeah. There's nothing dangerous about that. No more dangerous than, working on this stuff is anyway. But there you go. I just thought I'd mention that. So yeah, I want to see if it powers up. I've attached two old IDE hard drives, yeah. So it's actually got some sort of load now, and I want to see whether that means it stays on or not. Yeah. So everything's safe. It's all spread out. There's no staples. It can't touch anything. It can't do anything. There's no point using the light bulbs because we know this has PFC and it doesn't like it. Yeah. So all we can really do is now is just switch the power on and let's see what it does. And it powers up and goes off. So putting a load on there didn't make any difference. Let's have a quick look now. It's powered off. Let's just see if the big main capacitor's got any voltage in it. Yeah, we'll just come around from this angle. 60 odd volts and discharging. Yeah. So it's discharging itself. That'll go away. Right. Just start off with, there's probably a couple of reasons why this would be doing what it's doing. Yeah. First one is going to be it powers up the output rails, which you know they do power up. This control circuitry sees some error and it shuts back down again. Yeah. The other reasonably likely possibility is that the 5-volt standby is coming on and going back off, because if the 5-volt standby goes off, all this will power down and show the power, so that will power down. Yeah. So I think the next thing we need to do here is to see whether we have 5-volt standby when it goes off. Yeah. I could test on the purple wire in here, but I'm pretty confident that the 5-volt standby is coming from this power supply here. So let's have a look to see what we have coming out of here, yeah, when it shuts back down. Let's see if we've got any. And there's two voltage rails that I'm interested in. Let's have a quick look. What say we could measure on this connector. In fact, no, go on. Let's not do anything too advanced yet. Yeah, let's do it. The way I'd say if people are learning this is how to do it. Yeah. So purple wire and black wire in there. Yeah. Purple wire, black wire. Okay. We'll power it on again and let's see when it shuts back down if the 5-volt standby stays or goes. So the 5-volt standby is stable, yeah, the thing's powered back off again. So we have 5-volt standby. Now I'm a bit interested to see what voltage we have coming off here. There should be two supply rails here. This is from experience on previous ones, yeah. So let's try the black with, I'm pretty sure will be ground. Let's try the orange wires, yeah, let's see what voltage is on those. Nothing on those ones. So we've got the red ones. Assuming I've got a good connection here. No, maybe I don't have a good connection here. Or maybe the black isn't ground. I mean, I'm just assuming that black is ground, yeah. Let's try that. 5 volts. Yeah. The red's the 5 volts. So I'm thinking the orange is probably going to be another supply rail. Maybe 24 volts or something. Doesn't seem to have anything on it. No. Doesn't appear to have anything on that one. Just try checking down here where I can get at it a little bit easier, yeah. No, there's nothing on the orange one. That might be a bit interesting. But we definitely have 5 volts standby. Right, let's see if we can get a little bit further with this. Okay, so there's a couple of ways we could go at this. We could have a look around this control board and try and find the data sheet for the chips on here and see what they do and see if the power stays on there, yeah? If the power's going off there, obviously the thing's going to shut down. The other thing is I might just have a quick look, we may as well, to see if these orange wires go to one of the capacitors under here. If they do, then you'd assume that should be a power rail and there should be power on it, yeah? I've disconnected this now. I've disconnected the mains and the capacitor's discharged, so it's safe to have a look, yeah? So let's have a look to see where these orange wires actually go. So they go into this end here, these two pins. It's probably easier if I actually just unplug this, so I can get at it a bit easier. Just unplug easily. Okay, so the orange ones are going to these two at this end, yeah? And we know red is 5 volts, so we know black is ground, because we can measure the 5 volts there, yeah? So these orange ones sort of go into here. Wire link or something here. It don't seem to go anywhere. Let's interesting. Let me just zoom down a little bit on this for you. Okay, so the two orange ones are here, yeah. These are the black ones, so this is going to be, well, ground on the low voltage side. It won't go to hot ground anywhere on this side. This will be effectively ground, yeah. We can get the meter in here, so we just put somewhere you can see that, can't you? Okay, there we go. There we go. Okay, so we know this is ground. This is 5 volts here. So I'm guessing we'll see some resistance here. Yeah, I know, like 46 ohms or something to ground. So you'd expect to see resistance to ground off this rail as well, assuming it is a voltage rail. Looks like it goes to like a wire link here to here. Yeah. Well, that wire, no, it would be a capacitor. There would be a capacitor here. Oh yeah, it looks like there's some other components here that are not fitted, you know, like some capacitors and things. So I'm thinking now probably that isn't used on this. It probably is a supply voltage for some different board it connects to. So I think we can ignore that. Keep it in the back of our minds, but I think we can basically ignore that. That's a rectifier diode here. Okay, so that didn't really get us anywhere. So let's have a look to see what's happening. Let's get the data sheets for these chips on the control board, and let's have a look to see if we can see what's going on here. Yeah, right, we'll do that. Okay, I've had a good look around this. So far, I can't actually identify the switch mode power supply controller chip. I can't figure out where it is. I know on this board, this chip down here, you can see, this is a UC3854N. That's a PFC controller, and that's exactly where it is on the PFC, yeah. Another thing I've noticed, just interesting, is these 3 opto-isolators, one of them sends information the other way. So one of them, the LED is on this side and the transistor on the other side. They're all the same type, but one's mounted the other way around. That's interesting. I assumed that somewhere on this board here is the switch mode power supply controller. I see a small transformer down here, which would make sense to drive the output transistors. And if you look at this transformer, the wiring it kind of goes off this way somewhere. But I can't see a chip on here that would be the one. This one apparently it looks like it's a fan controller from the datasheet. The other two, one's a voltage comparator, which makes a lot of sense. The other one's a quad operational amplifier, which also makes a fair bit of sense. There's another chip down here that has a strange number that appears to be a thick film resistor network, like an accurate resistor network, which could make some sense if it's a comparator. There's another quad op amp down here, but I can't actually see a pulse width modulator chip. And yeah, I'm guessing there must be one somewhere on here. I mean, the other thought was that this transformer, as I mentioned, that drives the switching transistors, that kind of like comes this way. I was thinking, oh, that's the connector as goes down to the 5V standby. We know it's got 5V standby on it. Is the controller over there? Which would be seems a bit strange, but there's no reason why it couldn't be, because this is on the low voltage side, and I can't see if it is. If it is, I can't identify it. So at the moment I'm struggling to figure out where the controller is for that. I think a couple of things we can try here. One is to take this board off. Yeah, there's a few more chips down the bottom that I can't see very easily. I've had a good look around, and it's possible I've got a bad soldered joint on here as well, which would make some sense because this can kind of wobble around. But if we take this board off, then we can A, have a look to see what's actually on it, yeah, and B, we can then get to all these capacitors. And I think, although none of them look physically bad, the next thing with this, if we can't find the controller chip, which I'm hoping we can once this is off, is to start to pull all these capacitors, and there's a little one on this board as well, and have a look to see if we have any bad capacitors. And it was quite possible we have, even though they look physically okay, doesn't mean they are okay. Yeah, I'm pretty confident that this is working, but I'm also going to check just before I take this apart. I want to see if the PFC is running. I'm pretty sure it is, because we saw the pulsing when it was trying to start up with the light bulb connected. But another possibility, if the PFC isn't running, maybe this won't start up properly. Yeah. So let's have a quick look now to see if the PFC is running. The way to do that is to measure the voltage on this capacitor. If it's something in the region of like 375 volts or something like that, I know full well PFC runs. Yeah. It may be that it powers up and powers back down again, but we would know it runs. Yeah. So let's check that. If that looks good, let's get this board off so I can see properly what's on the other side of it, and then let's start checking all the capacitors, yeah, and see if we can hopefully find, you know, a bad capacitor with ESR problems, because that would be a good indication. Okay, let's just connect it back together and check the PFC. Okay, so I'm convinced the easiest way to check the PFC, and I've just stuck the wires down to this connector, yeah, this connector, because this feeds onto this capacitor directly. So we can see there's a little bit of voltage in the capacitor, yeah, fair enough. And we can measure this now, keeping our fingers well out of the way of it. So let's just watch the voltmeter. I'll just switch this on and we'll see what we get. Yeah, 378, and it stayed at 378. So we can say that the PFC is working. Yeah, we'll switch it back on again. Will it actually stay on? Interesting. Yeah, that stays even though the power supply is powered down, yeah, until I switch it off. So okay, so PFC is good, 5V standby is good. The other voltage that we thought may come from 5V standby seems to be an option on here. I can see where there's an inductor and capacitors down here that are not used, yeah. So this board's come off. See if I can identify the control, the pulse width modulator control for this. I need to find that. It's got to be here somewhere, yeah. And then we will have a look at all these capacitors, yeah. I think we can say the ones on the PFC are fine because the PFC is working. Okay, let's start desoldering some stuff and see what we get. Okay, so I've taken the board off. It's quite interesting. Looking at this board, I mean, this is a fan controller. Yeah, that's what it says on it. It says smart fan on it. And Googled for the data sheets. I couldn't find the exact data sheets, but it did say it was a fan controller. We have a quad op amp and a quad comparator, so there's nothing intelligent there. Yeah. Same on here. We have op amps, comparators, and we have this chip here, which I looked up the part number. It says 1002DS. I'll see if I zoom in on it for you. Zoom it down. Yeah, so this thing here, it says on it 1002DS. Yeah, can you see it? 1002DS. You will forget the focus bang on that for you. I think that's it. When it stops wobbling, yeah, there you go. 1002DS 7K25. And this chip here next to it or near to it is an EEPROM. It's a 27 why did that focus go out on this camera? It's mental. I mean, this is a manually focused camera. It shouldn't be able to do that. But this is an EEPROM anyway. 27C02. Yeah. And I'm thinking, well, first of all, why would you have an EEPROM on a power supply? That was a good question. Yeah. But if that's an EEPROM, then you think somewhere on here there must be a microcontroller, or a microprocessor, something intelligent. And at first I thought this chip here was like a resistor network from the number 1002DS, but it isn't, because it's got the wrong number pins for that data sheet. Yeah, it's not. It'd be a 24 pin. It's a 16 pin, and I can't find any information on it. I'm not sure what this actually is, but if it was a microcontroller, that'd explain why it's got an EEPROM, yeah. Although microcontrollers often have built-in memory, but it would kind of go somewhere to explaining why there's an EEPROM there. But if that was a microcontroller, surely you'd have a crystal. Yeah, and I don't see one. Not on either side of the board. So it's a mystery to me, that. I can't see anywhere a pulse width modulator controller on this. Nowhere can I see it. So I can only at the moment assume that this chip is it. Yeah. So that's interesting, because I can't find any information on it. Yeah. So you kind of think, like, I've come to a bit of an impasse with this one. You know, no information, can't find the controller. We can start changing capacitors. You know, we could also go for the other common things to go wrong with power supplies. Back in the day, at least, which was opto-isolators giving up. Yeah. So we could pull the opto-isolators. We could test them. There's only 3 of them. We can check the capacitors. But there is another way, you know. And the other way just happens to be this. This is power supply number 16, and just by some quirk of fate, or just because Richie's a jammy bastard, yeah, just because Dickie is a jammy bastard, yeah, it's exactly the same model. And this one is saying 5 volts is 4.1 volts, but it runs. So if this one runs, then we can kind of like start to eliminate the problem on the other one, because we have 2 circuit boards which we can take apart. Yeah, we can find out which circuit board has got the problem. That's the first thing we can do. Yeah. Second thing is we can do is we got this controller board, and we can take it off the other one and swap them over and find out, is the controller board the problem. And we should be able to narrow the fault down to either being on here, or on here. Yeah. That's the theory. So let's just zoom out and let's see if this other power supply does run. I wrote on it runs, so let's have a look. There you go. So we'll see if we can determine where the fault lies. That's a good way to go, yeah. And if anybody thinks this is cheating, it is. I mean, using another one, a known good one, or one with a different known fault, you know, using each effectively to diagnose the other, is a good technique. Yeah. If nothing else, we should end up with one good one here. Yeah. We might end up with 2 good ones, but you know, we might end up with 1 good one, but that's the result. Yeah. So let's power this one up and let's see whether it actually does what I wrote on it. Okay, so that's ready to test all plugged in. Just before I do that, I also noticed on this power supply, and both of these, have this weird connector just marked as P8. Yeah. Anybody got any idea what that is? Because I haven't a foggiest, to be honest, what that is. Yeah. And another thing I noticed on here, there's various coloured wires, but there's a blue wire. Yeah. And the blue wire goes to here on this board, and I'll show you what it says next to that blue wire. It actually says VCC EEPROM. Yeah. So if anybody's got any ideas, I mean, I could go on, say, Bad Capsule somewhere and ask. But yeah, why would there be an EEPROM on an ATX power supply? Yeah. First question. What's this funny connector do here? Yeah. P8, but apparently it's something to do with powering the EEPROM, or giving VCC. Yeah, VCC is the power. Yeah, to the EEPROM. So There used to be answers on a postcard, but of course we've got technology now, so answers on the internet. Yeah, answers in the comments below. Okay, let's just power this baby up and see what this one does. So again, I've put a couple of old hard drives for load. Oh, now that is interesting, because this one I swore had the output voltage low, and now it's doing exactly the same as the other one. Yeah. The only thing I can think I possibly did different last time is I didn't have a load, like, you know, the hard drives on it. Yeah. Let's disconnect the load. Okay, yeah, I've just disconnected the loads, and it does actually power up now, this one, and the 5 volts is 4.1. So we have one here that does power up. Maybe we can use this to try and figure out what's wrong with the other one, yeah, by swapping some parts around. So let's get on to that and see if it helps us to determine where the problem actually is. Okay, so this is the other one. I put an X on each of these, yeah, and I've also put an X on the board as well. So we can now do some very quick eliminations. I'm confident the problem is going to be on this board, yeah. So this is the one that was given as the 4.1 volts, yeah. So what we can do first is we can get rid of this. We can take our other board, yeah, and we can just connect it to this one, see if it does the same thing. Yeah, if it does the same thing, we know that this wasn't what was making it shut back down. Yeah. So there we go. I'll just find my magazines again, brochures, just to stick under here, give a bit of insulation. Yeah, there we go. Okay, still none the wiser as to what this thing's for. Okay, so we have our analyzer. Stick this on here. Making a prediction, I think this will do exactly the same. It'll just come on and give us 4.1 volts. Yeah. Quite why this one wouldn't power up with a load, I'm not sure. Maybe that's another problem with this one. But we can see when we get if we get the other one powering up, see if that powers with a load. Unless it's all something to do with this, and these things need some sort of signal to make them work. I don't know. I'm not even sure what they're off now. Okay, you can stick that in there. Yeah, get so it just stays still. There you go. Well, it's out. It stays still, but you can't see it now because it's off the shot. Yeah, it stays still, but you can't see it. There you go. Okay, so we need to power this up. Okay, so this is our original PFC board and 5 volt standby with the other one. Yeah, where are we? What do we have? We have everything we need. We just need power. Okay, stick that in there, and then let's switch this one and see what this one does now. Oh, well, isn't that interesting? Isn't that interesting? That's, yeah, that took me by surprise. Let's see again. On. Pew, off. Okay, let's just let this discharge. We'll just check the capacitors, make sure there's no high voltage in it, and then we'll stick it back onto the other one. Okay, just check this is safe. Yeah. No, still got 50 odd volts in it. Not really enough to give you a good zap, but let's just leave it a little, just to discharge, and then we'll swap it back again and let's see what happens. Okay, so I've soldered our little plug onto this one. Yeah, this is the one with the X on. So this is the one that, you know, we took out the case. It comes on and stays on, but the 5 volts is low. Let's connect this one up. The power's off at the moment. Let's see. This should do the same as it did before we unboxed it. Yeah, we uncased it. So this should just come on and stay on. No, that's doing the same as well. These are acting very, very oddly, in my opinion. That didn't prove anything much, did it? didn't prove a lot at all, because that's the one that was working. Well, 5 volts was low. Apart from when we first tried it without a load, it didn't work. I'm wondering about this now, you know. What is this? It seems a bit strange. I can't get them to do repeatable, you know, things basically. Yeah. Well, apart from that, it's repeatedly doing what the other one's doing. Interesting. I think, guys, I need more information. I want to know about this. I want to know what that chip is, and if it is a microcontroller, and why this thing's got an EEPROM on it. Yeah. And then I'll be back. We'll call that a video for now. It's an interesting puzzle, this one, to be quite honest. And I'll see if I can find any information out about this, and then we'll be back and have a bit more of a play with this lot. Okay, see you all soon.